Hello guys and welcome to this new tutorial. In this lecture we will be talking about the different types of circuit breakers. Now circuit breakers is a really deep topic, and in this course we are only interested in the circuit breakers used in industrial automation and not in the circuit breaker used in power distribution and power systems. So here we're focusing on three types of circuit breakers, which are widely and commonly used in every single industrial automation control panel. These types are MCB, MCCB, and ELCB circuit breakers. And in this lecture, we will explain briefly the differences and application in between these three types. Let's start with MCB. And I'm sure that you've seen these type of circuit breakers at your home. MCB is what's used in order to protect your home appliances, and it's also used in industrial automation control panels. There are too many brands for circuit breakers. I'm just picking a few of them right here. We have Schneider, ABB, Siemens, Wago, and a lot more. Now, what does MCB stands for in the first place? MCB stands for miniature circuit breaker. They can take up to 100 amps and they are used in overcurrent protection, overheat protection, and in switching. So what does all of that mean? Imagine an excessive current passing through your cable. Your cable diameter is small, let's say, and there is a huge amount of current passing. This cable eventually is going to heat up and it will cause a fire, making this cable flaming up. So to protect against heating, we use overheat properties of the circuit breaker to prevent that from happening. And the overheat reaction is slow, so it needs few minutes or few seconds to take a reaction. We'll talk about all of that later in this course in more depth. Overcurrent is when a huge short circuit current occurs, the circuit breaker will shut down and it will trip, preventing this overcurrent. So think about it like a fuse. Except that a fuse will blow up immediately while the circuit breaker will only trip, and all you have to do is turn it on again. Now switching is, as the term says, just switching on and off a device. So you connect a circuit breaker to the input of the device in series. So if you want to shut down that device, you just turn off the circuit breaker. If you want to turn it on, you just turn on the circuit breaker. Now MCBs come in three types: single pole, dipole, or three pole. The difference is how many cables you can connect at once to that circuit breaker. If we have a single phase system, we use a single pole, where we connect this single pole to the phase of the equipment we are trying to control or protect or switch. If you are interested in cutting off the phase and the neutral of a single phase system, we use a dipole. And if we have a three-phase system, we use the three pole. Now we should never connect three single poles together in order to protect a three-phase system. That's because the single pole, if any problem happened at only one of the phases and that single pole tripped, the device will be connected to only two phases, and this will cause problems in some equipment. However, using the three-pole circuit breaker, all the three poles will turn on and off at the same time. That's the advantage here. Take a look here how all the poles turn on and off together. There is no chance of one of the poles turning off before the other two do. Now let us talk about MCCB. They stand for molded case circuit breaker. Their rating current is much higher than the MCB ones, and they are rated up until 1000 amps. And they are usually used at the main input of your electrical panel. Now, the most important characteristic here is that usually circuit breakers come with a pre-adjusted parameters for when should this circuit breaker trip. However, in MCCB, you can adjust these parameters. Say, I want my circuit breaker to trip at 10 amps. So you just, you have a knob and you rotate it and you adjust it to 10 amps or 20 amps, depending on the type of the circuit breaker, the manufacturer, and we will talk more in depth about this stuff later in this course. Now, our third and last type is the ELCB circuit breaker, which stands for earth leakage circuit breaker. And as the name states, whenever there is a leakage from the circuit to the ground, this circuit breaker is going to trip, cutting the power. So it's used at the input of any electrical panel. Now, usually it's not used in the automation panel, but in the panel that is distributing power to your automation panel. Because in factories, you might have a couple automation panels, and it's important that you protect the factory as a whole and not just a portion of it. So they use it at the main electrical input of this factory. What it does is it monitors the free phase and it monitors the current going back to the source through the neutral. So what's important for you at this moment is to understand that ELCBs are used against electrical shocks. So if somebody touches the phase line by mistake, let's say, a leakage current is going to pass through from that phase line to the ground, causing this ELCB to detect that there is a leakage and tripping, cutting off the power to prevent serious hazards. And the reaction of ELCB is so fast that it is literally within milliseconds it can cut the power off if there is a serious hazard situation.